Okay, this is the review video for the equilibrium test. This is brought to you by Multi Mavericks Fitness. Here are the answers for all of the multiple choice. And remember, I did make an announcement, quantitative reaction or whatever that question was, you don't have to know what that is, that won't be on the test. This is what you need to know, everything that was covered in the package, plus the questions that we did today for Gibbs free energy and for solubility. Again, the questions are not hard, they're not difficult, it's just you have to watch your calculations, you have to make sure you get everything correct, and you just have to know what to apply where. Like we said today, Q is not the rule of 100, they are not connected in any way. Make sure you understand what you're doing before you go ahead. If you need the screen, please just pause the video and then you can move ahead to the next questions. So this is the answer to the first question. Granted, this kind of question I would not ask you on a test because it does go to the power of 5, but I'll just quickly walk through it. You don't know what your products are, but you are given the concentrations of your reactants at equilibrium. And this question wants you to assume that you had nothing to begin with for products. So your final is plus X, and you had 4 moles of hydrogen, so that was plus 4X. When you put this into the equilibrium expression, you have to put this to the power of 4, and this one here will be the power of 1. And the ones at the bottom, because this one I believe was H2S, and it was 2 moles, you have to square it here. Now, there's one point I'd like to bring up, which I've seen some students struggling with today. When you're given a variable, so you're given an X, or for solubility, you're given S values, the coefficient has to be there plus the exponent. Okay, both of them have to be there when you have an unknown value. Like in this case here, we have an X. When you have a known value, so over here, our molarity is 0.36, you only use exponent. There is no point of putting a coefficient there. The coefficient is stating that we are multiplying this value right here, this 1 mole value, by how many moles we have. When we have a number value, that means all the moles are already present. So there's no need to put any coefficients here, you only use the exponent. When you work out the math, this comes out to 256x to the power of 5. Once again, I would not ask you, the most I would ask you is cubed for equilibrium. For solubility, it can go as high as it wants because there's nothing to divide by. Nonetheless, when you solve for this, you get x is equal to 1.03 moles, so that's the value of CS2, and then H2, because it was 4 moles, we get 4.12 moles. Again, pause the screen if you have to, and you can just walk through it at your own pace. The next question here, ammonia and into the breakdown of nitrogen and hydrogen. Here you told that ammonia, you started off with 3 moles, and you finished off with 1 mole at equilibrium of hydrogen. Easily you can conclude that if you divide this by 3, because this is 3 moles here, you get the value of x. The value of x comes out to 0.33. So similarly here, you subtract 0.66 because this change here of ammonia would be minus 2x. So 2 times 0.33, you get 0.66. Here you have 1, 2, and 3 equilibrium values. You substitute it into the equation, so products over reactants. And once again here you see we only use the exponent value when we have the values given. So all the molarities are present. We only use exponent values. We do not put any coefficients over here. Don't put any coefficients in front of the values here if they are given to you. And the K equilibrium value was already given. You calculated, this was the unknown. So you calculate this expression right here and you get the value. Once again, no units for K because that's how it is. I would highly recommend that you understand the difference between when you're solving for X versus when you're solving for K. When you're solving for K, generally you have values, numerical values that are given, then you don't have to use the coefficients in front of the number. So I'll just give an example here. You have a number and it's 3 moles, so you cube it. You don't put the 3 in front of it. There's no coefficient needed. However, if you had a value of x, then you would have to put, if it was for example 3 moles, the 3 coefficient and the cube at the top. I hope this clarifies any confusion that existed today. Okay, third answer here, magnesium carbonate, and breaks down into your magnesium ion and your carbonate ions. Excuse me. Now, if you're given the mass, you can find out the number of moles, and you're also given a volume, you can find out moles per liter. So molarity is pretty easy. You're just canceling out units, so this cancels out here, and then liters would cancel out from the moles per liter. Sorry, the liters you would include it with moles per liter, so you would get big M. And because magnesium is 1 mole and carbonate is 1 mole, and because they came from the same species, you could just square the value. So that's why you'll notice here it's squared, and you'll notice there's no 2 or anything in front of it because it's not necessary here. And final question here, silver nitrate and sodium chloride, you get a dual displacement reaction, so silver chloride and sodium nitrate. For tomorrow, it is fair game that you can assume that any sodium or first group salts are soluble, always soluble, in any nitrates. So NO3 is a nitrate. Anything that has a nitrate, also soluble. This is not a concern for this question. It won't be of concern for any solubility question. Anything that has a nitrate or anything that has a first group element. So the one that we want to focus on here is our precipitate, AgCl. So this question right here, you have 0.45 moles, and this is how many liters it was originally that we're starting with of AgNO3. But because we mixed 2 volumes together, you have to divide it by the total volume after you mix both quantities. And then you notice for the same thing for Cl, we had a different molarity and we had a different volume, initial volume. So this is initial molarity and this is initial volume here. But our total quantity at the end was the same because we added 2 things together. It would be the same for solving for silver and solving for chlorine. But your initial quantities, so your initial molarities and your initial volumes here, they will be different. You calculate those on the top and then divide by the total volume. So ion product then, because it is a 1-to-1 ratio, it comes out to Ag, whatever the value you got for Ag, so whatever that molarity was. And then whatever molarity you got for chlorine, nothing is squared because this is exponent 1. And you just multiply it across, you get 1.4 times 10 to the power of -3. And because this value is greater than the KSP that was given to you in the question, you can say that a precipitate forms. Now let's say, just for example, our product here, it looks something like this. 2AgCl. Now this doesn't exist, but let's just assume that it did for just sake of clarifying things up. Then our product here, so this would be Ag, and then this one would be Cl minus. So Cl, because it is 1 mole here, it would exist as 1 mole as an ion. So we would just put the molarity in, it would be to the power 1. We're done with that. However, Ag over here, we find out what the molarity is, so same as we done up here, not a problem, it's just routine calculation. But because we would have 2 moles of Ag, we have to put a square up here. Don't put any 2 here, because this value over here, the molarity, is already calculated. It's a numerical value. You don't have to do anything with it. That concludes this chapter. It was a really big chapter. I would recommend that you go over any questions that involve Q, go over any questions that involve ice table, understand the differences between ice table, so for K equilibrium, and the differences between KSP. Because granted, even though they look similar, there are fundamentally some things that are different that you would have to know about these. And also for Gibbs free energy, you're either solving for delta G, so you would say if it's positive or negative, it's non-spontaneous or spontaneous, or you would be solving for T using what we learned today, which is delta H over S. H values and S values you will be given. Remember to calculate these is products minus reactants. Be sure to use the appropriate phases. Other than that, that is the end of this chapter. Next is acids and bases, but we can worry about that for Wednesday. I'd also like to thank you guys for this opportunity and this experience that I've had. It was one of the best in terms of teaching, and you guys were an awesome class altogether. I'm going to miss you guys. Thank you very much.